All right, welcome back to video series 2 of this Svelte 5 reactivity system under the hood demystification. If you haven't watched the first video and you're kind of new to signals, I recommend you watch the first one. But even if you don't, you will probably still pick up a few things here. So deriveds, when you should use them and when you shouldn't use them. So the thing about deriveds is if you understand signals, signals basically have what's called nested reactivity. And what nested reactivity means is that every time something is called like an effect or a derived, every time a derived expression is evaluated or an effect function is called, it creates a global context from which anything that runs within that context, no matter how nested it is, if there's a signal that's retrieved, it will create a relationship, and that effect or that derived will become reactive to said signal. That was a bit of a mouthful, but I'm going to flesh that out in a second here. So the thing about that is you don't actually need to use derived, basically ever. So I'm going to show you that. So let me just set something up here. All right, so I've set up a tiny little Svelte 5 script here. So we have a name, which is a state of world, and we have a character as a name, which is derived, and the derived is name.length. Now let's just peek under the hood for a second and talk about this a little bit. Don't be intimidated by a lot of this. A lot of it's mostly just like HTML manipulation. But if we look for the kind of reactive part, you'll see this. So this is the compiled code, right? Now, if you remember the Svelte 4 compiled code from last time and how it had those dependencies set up, I gave like a little bit of a, there we go. Like this is sort of what the equivalent might be, something like this, not exactly, where the dependencies are already the dependencies are already specified at compile time. But here you see this: the dependencies are not specified at compile time. There's just the function, and that function will get called with this derived. So it creates a state, which is a source, and then it creates a derived function, and that derived function or derived rune, sorry, with using a function. And so when you pass a derived name.length, this isn't evaluated just once. It's actually in the background. It's converted into a function that gets called, creates a context. Every time it's called, anything that it retrieves, any signal it retrieves, will create that relationship and the reactive relationship, right? Okay, so hopefully that all makes sense, at least somewhat. But let's take a look back in this, because that was a little bit of a review from the last video. So if that's not super clear, I recommend watching the first video. But anyway, so any character that I add here will change this characters in name. So if my name is Pete, I have 4 characters, right? Everything works the way you would expect it to. Now, in Svelte 5, you can do something like this. I could say characters.name is equal to some function that returns name.length, and then I can call that function in here, and it's reactive, right? So you don't really need deriveds at all. And when it comes to classes, you can just create getters, and a getter will just call the function that returns the evaluation of. Now, if I went into a svelte.js file, now if you look at this file, you'll notice it's not a JS file, it's a svelte.js file. And I went over that a little bit in the previous video, but this basically will allow you to use some of the magic of runes in your library files, which will allow it to be kind of consistent across components and library files. You don't have to use it though. If you have a normal JS file, you won't have any kind of compiler magic on top of that. But it's just an added convenience. It's sort of like a blend between compiler magic and plain non-component JavaScript or TypeScript. So I have an animal here with a fur length of 3. Not that it matters how long the fur is, but if I were to have a derived, I could say fur too long equals derived, something like this dot fur length greater than 5 or something like that, right? Or I don't have to do that. I could also say get fur too long, and then I would return fur length greater than 5. And actually those two, really in essence, from a practical perspective, are kind of the same. So I can just, let's say, import my animal, import animal from animal.svelte.js here. And then I could say let zebra, or zebra as they say here in the UK, equals new animal. And then I can get this like zebra here. Okay, just get rid of that. Zebra dot fur too long, was that what it was? Fur too long? No. Yeah, fur too long. That is what it was. Fur length not defined. Oh, this dot fur length, right? So fur too long is false. Why don't we create a button that grows the fur? So on click, zebra dot fur length plus, right? Grow fur, grow fur, grow. There we go. See, so either way, whether I use this one or whether I use a derived, like it still works because of nested reactivity. Okay, so when do we use derived and when do we not? And the answer is not super simple, but I'm going to give you all the factors, and I hope that in doing this, it will kind of give you an appreciation for how much stuff is really going on under the hood. All right, so the thing about deriveds, so most people will say in this debate, you might have heard this before, about how you should only use deriveds essentially for computationally heavy tasks. If you have something that takes a lot of processing power, well, the derived will act almost as a cache, right? So it will be able to know when it's marked as dirty. It won't run when it doesn't need to. And then when it's called, it will evaluate, but it will only evaluate when it knows that some of its dependencies have changed. And so in that way, you have kind of a caching thing. So if you're using, let's say some sort of graphically intensive process, and you need to know some sort of complex mathematical formula for I don't know, some character going down a street in a video game or whatever, you might want to use that. You might want to use a derived because you won't have to recalculate that every time you use it. If you're using something just once, then okay, actually, let me show you this. So what you're looking at right now is not Svelte. This is my own framework that I wrote. It's designed to be a Svelte/signal aid. So the Svelte source code is pretty complicated because it has a lot of optimizations and a lot of HTML stuff, but this is pretty simple. And it mimics the Svelte signal system, not the HTML side of things, but the signal stuff. Almost, it's pretty close, close enough that you can kind of see it. Now, the whole point of this is that I can hook in a visualizer, so you can actually see how things change, basically like things that get marked as dirty, when they're run, the order in which things are run, things like that. And we'll be going into this in a little bit more depth in the next video. But for this one, I just want you to see here. This is the case if there's if I'm using a derived. Now, if you look here, there's 5. Oh, let me run you through the code a little bit. So I created 5 sources, which is essentially 5 states. Then I console logged them so they wouldn't get garbage collected. And then I created derived, which is basically the total of all of them. And I put a little loop here. And basically what it does is it creates a span. And then it creates an effect that says, that passes this function. And that function basically says, set the span's inner text to the total. And then it appends the child to the parent container. Now this effect will mark this as reactive when it gets to it, and so whenever total updates, it will rerun the effect, as we've kind of discussed a little bit previously. And but for right now, the loop is only set to 1, because I just want to show you the simple notion. So using derived, we have 1, 2, 3, 4, 5 dependencies connected to this, and a 6th that goes to this span, which is basically the effect depending on the derived, right? Green is effect, red is derived, blue is the source. Now, if I change this, let's say if I create a function instead that is basically, well, actually, you know, I can put the function in here, that basically returns this. Let's call it total sum. Actually, let's call it fn total. I can't spell that. So if I put fn total here, what's going to happen? Well, it's still going to be reactive, right? I didn't put any like buttons in here and stuff, so I'm not going to show you that because you don't really need. It's not really part of the thought experiment. But look how many more dependencies there are. So actually, let's remove this here because we don't need that anymore. So this is actually the same. Yeah. So I meant that. Okay, if there's one, right? If there's only one effect that comes from these, then the only thing you have to think about is like whether you want it to be cached in case it's run again. Like if this effect is destroyed and then another effect comes along and accesses the same thing, it will rerun this whole function again, right? And actually, you know, maybe it's better to picture if we have like 2 of these, right? So now that we have 2, you can see that each span has depends on every source. And like if you want to use sort of a oat kind of notation, it would be like a n times m. So anytime we increase the amount of sources, you'll multiply the amount of connections by how many effects depend on it, right? So if we end up with 5, like that's 25 connections, right? But if we use that source instead, get total, if we use that source instead like this, you'll see now there's 10 connections, which is an n plus m. So it's not all about computational intensity. It's also about how many connections you're making, right? If this is super fast to calculate, who cares? 10, 20, 30, whatever, it doesn't matter. But what's happening is every time it's running, it's setting up all these connections all the time. And so if you don't use a derived, you'll basically create this kind of MXN relationship network. But if you do use a derived, then not only are you caching the something computationally intensive, but you're also saving the amount of wiring there is. Now, signals are pretty hefty things. They're not small objects. I think, if I remember right, every signal has maybe like 10, not 10, like 7. I don't know, you can look this up yourself in the source code. I don't really remember, but something like 7 properties on them. And they have like several arrays and stuff. And so, you know, this is things that you should be thinking about um, if you have a lot of repetitive code. Like, for example, I have an app where I have highlights. And if I had something like this for every highlight and there were thousands and thousands of highlights, yeah, it'd be good for me to use some derived somewhere. It'd be good for me to use some, to think about, or maybe not use deriveds in some cases because that's heavy. But like, if you think about the relationship and how things grow as they expand, like how this would play out, that will allow you to make an educated assessment as to whether to use a derived or not. Because the truth is, you don't really need them. And sometimes they just clutter your code. Sometimes it's just like an extra rune when you can just create a function that returns a value, you know? Um, so there's many factors, and a lot of it comes down to personal preference. Not preference, but like, there's no hard and fast rules for every situation. But if you understand that the advantages of deriveds and the disadvantages, well, then you can just make the best decision. So just to review, deriveds, they they're kind of hefty objects. They have every signal has about 7-ish properties on them with some arrays, dependencies, reactions, these kinds of things. So they're not that light at scale, but they also save computation because they cache the value of whatever the evaluated function is. So they offer that. And also, in cases like this, where you have a lot of effects accessing some function that has a lot of dependencies, well, deriveds can not only save computational power, but they can actually save the amount of connections that need to go. So rather than having if A, B, C, and D, if all that is M and all these effects are N, instead of having an M x N amount of connections, you have an M plus N amount of connections, which is it's just better optimization for large complex code bases. But these are things that you don't have to be picky about this stuff. You don't have to think about it to the point where you're in your head over engineering things. That's not the point. This is more about kind of understanding signals, understanding what they're about. Okay, so that about concludes it for this video. In the next video, I'm going to be talking about what I think is the most important thing to understand about Svelte, is this thing called the microtask barrier, or at least what I call the microtask barrier. And it's the reason why you shouldn't have side effects in deriveds. It's the reason why you're encouraged highly to be using deriveds everywhere that you should instead of effects. And so I'm going to be going into detail into that. If you don't go to the video after that, I'm happy. The main thing, this to me is the most important thing. So please do watch. After that, you're free to do whatever you want.